Hey there, folks. So, last episode we set up hunger and thirst health damage for when you're dehydrated and you're starving. We added in an exhaustion component for when you have used up all your stamina that blocks your health stamina regeneration. And we went through and just did some cleanup with our stat line. So, as I mentioned, in this episode, we are going to be covering the save game component, or at least starting to cover that. And the reason why I say that is your save game component is actually something that you end up working on throughout the lifetime of your project, pretty much, up until you're on just the final bells and whistles point where you're just making everything look nice and you're not worried about any additional data that needs to be saved. So with that, the first thing we need to do here is actually go over to our content browser. Let me bring that into screen here. So we are going to actually be adding 3 classes right at the start of this episode. So the first one we're going to be adding is the save game. And this one is a fairly simple class. We're not going to be doing much to it once we do get to that. It is just very basic class here. And for that, I'm going to be adding this to the game folder. Again, folder structure is your own choice. I like to try and keep things as organized as possible. So we're going to create that. And Visual Studio here is going to request that I reload. We're going to wait until we're done adding all 3 of those files, though. And as you can see, I launched the editor directly. I didn't do it through Visual Studio. So I'll hop back over to, oh, it's not letting me right now. Let's hop over. Nope. Let's try minimizing this. There we go. So while all this loads, I'm actually going to run through a few things with you guys, just so you have a better understanding of the direction I'm going. The first thing we need to think about is how we're going to be identifying all of the different actors that are going to be having their data stored. You could go through and create a save entry for every actor you add, and in smaller games that may work. You don't need to worry about any form of unique identifiers. If you can say have 20 actors that you need to worry about the data, and that's it. No, we're not going to reload that. We're going to go back to project. Live coding up here. So with that, the other option you can do is you can add in a unique identifier of some kind per actor, and that unique identifier is used to just that, identify the actor. Now within coding, for anyone familiar, there is something called a GUID. Let me just pull up some information on that, just because I like to be precise with my information. So with that, a GUID is a global unique identifier. It is a 128-bit text string that represents an identification. And it looks something like that. And this is going to vary, depending. And then just quickly, how many GUIDs are possible? I'm not going to try and actually pronounce that number, but for a rough idea, hundreds, thousands, millions, billions, trillions, and then I can't remember, septillions, non-gillions, something like that. It's a ridiculously large number. So this right here is actually a very good solution for a project that needs a dynamic number of actors. It's going to change. It's going to go up. It's going to go down. Things like that. So first off, right there, that is something we're going to want to use to identify all of our actors. And actually, while this loads, I'm going to move this off to one side and open up Visual Studio so I can give you guys a rough idea of what I'm talking about. Reload all. We can do that multiple times. Well, actually, I say that, and live coding has just finished. So we're going to go back and add in these other ones, and then I'll keep talking. So back in the content browser, we're going to go right click again. And the next thing we're going to do, I dislike that sometimes. The next thing we're going to do is create a game instance. Now, for anyone who isn't familiar, what a game instance is, it's a singleton. And again, for those that aren't familiar with what a singleton is, what it is it is an object that is created once and can only be created once. And in the case of the game instance with Unreal Engine, it is something that is created as soon as the application, your game, is ran, and it is there until the very end when your game shuts down. And it's never deleted or destroyed in between those 2 points. So any information stored in there is retained when you move from level to level and things like that. And that's a perfect place to store dynamic information that you want to be transferred from one level to another. And it's also just a good place to store things when you need to store that information. So we're going to create that class and bring back live coding. This should actually go pretty quick. Visual Studio wants to reload again. We'll say reload, it's not an issue. And go back to Unreal, bring up the live code. Anyway, so I'll just keep talking while all this loads because there is a lot to talk about in this episode. So as I was mentioning, the GUID is a perfect unique identifier to use for your save game. And we'll be covering adding that in either at the end of this episode or actually at the start of the next episode, in a way that you can guarantee you're going to be using a unique GUID. So the next thing to think about is, well, what sort of information, and this is why I was going to Visual Studio actually, so I'll bring this back up. What sort of information are you going to want to include? Let's just do a bulk comment here. So you're going to want to include, we'll just think about the player character to start with. You're going to want to include their location, their rotation. Depending on your game, you may want to include scale. Well, that's an easy one. All three of those can be covered by a transform value. And then there's going to be other things like you're going to want to include their health, stamina, in my case, hunger, thirst, because you don't want the player to save the game, reload the game, and all of a sudden their health, stamina, hunger, thirst, whatever stats you've got, come back as full. Well, that's a glitch. It's very easily exploitable and not something you want. Then there's going to be other things like, okay, you want to store their inventory, any money they may have, any experience, things like that. So, and this may just be you play a character. Let's take, for example, the game I'm hoping to make here. I'm going to have harvestable trees. So, well, what information are you going to want to store for that? Well, there's a lot of different things you can store for that, and it all depends on how big you want your save games to be as well. Like for harvestable tree, in my case, I'm just going to be including was harvested a value, and that literally knows, like, we'll say I haven't done the exact debugging and testing on that, but let's say it's 3 hits with an axe and then the tree comes down. Well, if you hit it twice and then you save your game and you reload your game, you're still going to have to hit it 3 times. I'm not going into including the number of hits because like that is, you're starting to bloat that. And just imagine you had a player who wanted to try and bloat your game save, and they go around and they figure out that, oh, if I hit a tree twice and save, it adds that. And then they go and just do that to every single tree in the game. You could eventually end up with a save file that's corrupt just from the sheer bloat. And these are things you need to take into consideration. So anyways, I'm going to clear this out because this isn't actually relevant for the game instance. Are we done with the live code yet? Yes, we are. All right, so back in, we're going to add that third class I was talking about. And I forgot to add this into there. Cannot move. So I will be fixing that later on. We can deal with that at another point. The third thing we're going to add is actually an interface. So we're going to scroll all the way down here. Unreal interface, your interface object class to be implemented by other UObject based classes. Interface, going to put that in the interface folder, and then save actor interface. Now, I'll go into a little more detail of why we're creating this interface a little further along once we start getting into some more of the actual code work. But for those who don't fully understand what an interface is, it's a way to say, okay, I have this interface. I have, we'll say, 4 specific functions in there. And it's a way to have any class be able to talk to another class and know it's going to have these 4 functions that it can do. So again, it's hard to explain. We'll cover as we go through that. So anyways, we're going to create that. Now we have those 3 files created. We're going to reload there. And we're going to, in here, in your Solutions Explorer, you can go through and you can move these files into the folders, but that is only going to affect it here within Visual Studio. It's not going to affect it in the editor. What we need to do, and actually let's close out of the editor here so that we don't have this running. We can do these other changes. What you do need to do, so let's go open folder and File Explorer, bring this over. So we need to go through here into your source, go through, and you can see here in the public folder, we have our game instance, which we've already got open, and apparently I double clicked that, which is not what I was trying to do. What we want to do there is move this folder into game, go into private, move this into game. Now in here, we're going to have to close out of the game instance files, and what we actually need to do, because they're no longer there, I found the easiest way to do that. You just select both of them and remove, and then you just add them back in. So add existing source. Which one am I on? This is the private. And then public game instance. All right, so now we've moved those in, we've got those back. You can see we can open them up. They're not present. What I like to do after adding in these classes, even though the live code editor worked, and you guys can't see me doing air quotes here, worked and set everything built, that is just runtime memory. It gets wiped as soon as we close the editor. And now you can see in here, we have a build error. This is likely from how I fixed something. So game instance.cpp. Oh, that's because we are missing. There we go. We are missed fixing that file path. So let's try this again. So this is the other reason why I said to build is we moved some files around. Folder paths may not be correct. There we go. We fixed it. But anyway, so now we've done that. Let's go through what I was talking about at the start there. This will eventually fix itself. This is just IntelliSense being slow. So we'll start by getting this set up in here. So as I was mentioning, you want to start with a GUID for your actor ID. And in Unreal, they actually use, I'm going to have to wait for this to load for that. Is this one that works? Let's see. No. Well, what we can do while we wait for IntelliSense to catch up, actually we can start by defining the struct that we're going to use for our save data. So as I was mentioning, you're going to want to save a bunch of information for your individual actors. So I'm going to start ustruct blueprint type. And again, this is so if we need to do any logic in a blueprint, we can still use the same information. Just because this is a C++ project does not mean blueprints are not going to be used. Yeah. Save actor data. Data, however you want to pronounce it. I'm not going to get into phonetics. So, and then it's the generated body ustruct. Again, you can use whichever one you want. I just use ustruct because it is for code clarity. Now, in most cases, you're going to want to use private variables with getters and setters. But because this save actor data is well, it's short-lived. So I was trying to think of the right term to use there. Personally, I've never gone as far as worrying about putting it as a private with getters and setters, just simply because it's short-term memory. And honestly, if somebody is going to be putting in the effort to hack your single-player game to this extent, then they're going to do it one way or the other. So, and again, to that point, actually, this is only because this is a single player game. There's zero intent for online multiplayer, things like that. An online game, you're going to want to add in a ton of additional security and anti-hack measures. And it's just the way that is. So, but anyways, so in here, let's say we want it to be a public in this case, property visible anywhere, blueprint read write, because as I said, we want blueprints to be able to modify these if need be. So the first thing, as I mentioned, f transform, actor transform. The next thing we're going to want, and this is for your serialization, and it helps keep things as automated as possible within the save. There's going to be things that can't be serialized for one reason or another, but we want a T array of uint8, and this is your byte data. And then we want, as I mentioned, for things like a runtime spawn, like say you've got a spell that you've got a fantasy game summons a fire elemental, and you save your game while that fire elemental is out. Well, you're going to want to know you need to respawn it. So bool was spawned equals false. That's one we can set there, because the majority of actors saved are not going to be spawned, so you can give that a default value. And then this is also, again, for that you need to respawn an actor that was created at runtime. You also need to know its class. So uClass pointer actor class. Now there may be some additional data you need to store in here as well. You could need to store individual components. You could need to store additional information that's not captured as part of the serialization. With that, and I know from experience with this project, there is additional information that's not saved. We will be adding in some additional storage classes to the bottom here. But for now, this is the very basics we're going to be starting with. So as you can see, I've added this into the save actor interface header. And the reason for that being is this is going to be exposed to every single actor that's going to be using the save game functionality, or is going to be interacted with save game functionality. So this is putting it in a place where every class is going to know about it, that needs to know about it. You could go through and add it to its own data type and then start including that. I just found I like to reduce the number of includes where possible. It also saves with a lot of recursive includes. Thankfully, like by default, you get pragma once in here. Personally, I'm not a fan of the pragma once, but it does what it needs to do. So anyway, so we've got this here. That is our basic data structure for storing our save game information. And what I'm going to do here, I'm just going to grab this include. And we are going to go back to our game instance. So our game instance header here, which is still not wanting to fully load. So I'm going to throw this here. And okay, because we move this around, there might be some issues here. So what I'm going to do is I'm just going to quickly pause and reload Visual Studio. All right, so even reloading it didn't work. So just for the sake of ease, because I want IntelliSense to work here, we're actually going to go through and recreate that. So open folder in File Explorer, go through. And this is just because, again, I opened it in, or created the game instance in the wrong folder. Tried moving it, and in this case, not interface game instance. So we can close out of that. We can remove it from here. We can build. But yeah, this is all because I created it in the wrong place. So you guys will have been seeing it in every episode. I end up doing something silly, and I keep those mistakes in just because, well, I want you guys to see, yes, these are mistakes. These are how you can fix them. So I will be back once this is built, and I will have the editor open just so we can recreate that file. All right, folks, we're back here in the editor. So we'll just quickly fix what I had messed up. So we're going to go into the game folder just for certainty. New class, and this is the game instance that we're creating. Game instance. You can see we're in the game folder, and just give that the name TF game instance. So we're going to create that class. Visual Studio is going to ask to reload. I'm going to reload all. It's now in our content browser, Solution Explorer. I'm actually going to get rid of the live coding. We're not going to do that. And we're going to be closing out of the editor right away as well, because we don't need to be in here. So when the editor actually responds, come on. There we go. Okay, so as I was mentioning, we have our struct here, which is going to be used to store actor data. This is pretty basic. But what we're going to do here, just as I was trying to do, quickly grab this header file. We're going to go over to our game instance header file, and we're going to include that there. And the reason we've included it here instead of the source file is simply because we want all of the information that's in here, be it the structs, any other data structs we may add, or other data types, as well as all of this. We're going to want to know about it. I do understand we could get away with putting it in the source file. However, for this purpose, I'm putting it here in the header. So to get things started, private. So as I was mentioning, we need to use we want to use a GUID to identify our actors. Well, in Unreal, you have the F GUID, just because it uses the Unreal formatting of F. Now, with that, because we know these are unique identifiers, nice thing we can do there is use that as the key in a map. So I'm going to go actually T map F GUID, and then we have F save actor data. Now we could have done, as I was mentioning, we've done in other things like struct F save actor data, but we don't need to because we actually know about it courtesy of the include that we had. And this is going to be savable actor data. Now, some other information we are going to need in here. We're going to need a pointer to a save game. So we're going to go class, and actually I'll just show you in here. It uses a slightly different format. It's your save file name. So grab that. Pointer save object, actually save game object. We want to have clear naming. another thing, and this is going to be dependent on your game. If you only want one save game at a time, that's fine. You don't really need this next part. But if you want your player to have multiple saves, then you're going to want to do this part. You're going to want something along the lines of an F string save game name. And for this, I'm going to be providing a default value here because I don't want there to be an exception, because at some point I forgot the code or forgot to set a save name. And then another one is if your game has multiple levels or say sub-levels, think Skyrim, Fallout, how whenever you go into an interior cell, it loads up a new map. If you're going to have something like that, you're going to want to know what map you are on as well. So F name, just because that's how level names are used within or referenced within Unreal Engine as a name value. Currently loaded level equals default. And actually for this, because we're not loading a current level, let's put that as none. So right here within the game instance itself, this is the basic information we're going to need. Now you're going to want this information also in your save game object. So we can actually do this pretty easy. We're going to grab that. I'm going to go to our save game, private. And I'll show you about using that struct here. And then we're also going to want to store the currently loaded level. And so with this, to explain the save game object, actually, as we're here, the save game object is just a utility class that the Unreal Engine uses, and it will automatically saves all the information that's stored in here with one key point that's required. All of these need to have a U-property decorator. Doesn't need to have anything in there for attributes, but you do need that U-property decorator. So we'll actually clean up the save game class quickly because this is really simple. So we have the ability to put the information in this object. However, public. I'm typing, reading, and talking at the same time. My brain does not like triple tasking. But anyways, so with that, we have these data objects or variables within the save game, but we have no way to access them. So it's actually pretty simple. We have 4 functions we're going to be adding to this class, and then we're done, at least for now. So we want void set save actor data, and that is going to take a map, and we're just going to call that data. We're going to have a get a save actor data that has a return type of that map. We are going to have a void set current level, which takes an F name, const F name, not going to use a reference here, level, and we are going to have a F name get current level. We're just going to quickly define those. Now we are going to need to add that include to the source file. Which one am I missing? Oh, get save actor data. Okay, so we want to grab this include here and add that into the source file just so we know about that. Get rid of that. So this one is very simple. So literally savable actor data equals data, return savable actor data, currently loaded level equals level, and return currently loaded level. So really this is as simple as the save game needs to be. Now, if you're wanting to include additional information in here, so you want to include save specific configurations, things like that, you would include those in here. You would either include them individually as each configuration item as a line item, as a struct, however you want to do that. But that is going to be dependent on your game. Well, I will say later on in the series, we will be getting to doing things like game level configuration. But I'm trying to run through things as we're going. I'm not trying to go, okay, here's my entire save game object, because, well, most of it doesn't make sense right now. So, or wouldn't make sense in the context of what I've already showed. So for now, anyways, we are done with the save game class. We're going to close out of that. We do still need to do some work on the save actor interface, but right now we're going to do more work within the game instance. So as I mentioned, the game instance itself is something that's created when your game launches. If you do need to have anything like you want to see, okay, what save games already exist, things like that, you're going to want a constructor. TF game instance. And in this constructor, that is where you would do things like, okay, the game started up, we want to look at what save files already exist, things like that. There is a couple other additional functionalities we're going to want to add in here. So specifically around that save game object, you do need to create the object to write the information to it. So we're actually going to have a function void, wow, I can't type, void create save slot. And the other thing we need to do is we're going to need a couple of different ways actually to populate this data. So running through that quickly, you're going to have a situation where, say, you have going back to my harvested tree, you're going to have a situation where your tree's been harvested and it wants to make sure that that's passed through. So you can have logic that, okay, tree's been harvested, pass off to the game instance that you've been harvested, and then the next time it's saved, it's stored. You can have things where on actor unload, so you move far enough away from an object that in memory it unloads it. So what you do is you pass through certain bits of information to your game instance then, so that when the object comes back in, again, you're thinking open world here, things like that. But then also you have, like, let's say quick save, somebody hits F5, you want the game instance to be able to go through and grab all the information then as well. So we're going to add in two functions here. One is going to be a private function that is going to be used for things like quick save. So it's going to be void gather actor data. But then we're also going to want to add in a public one, and we want this one to be callable by, or accessible to blueprints. So u function blueprint callable void add actor data, and we want it to take an fguid and an fsave actor data, actor ID and actor data. Now, as I was just mentioning, we also want a way for an actor to be able to pull its information back out. So we want an fsave actor data, get actor data, fguid actor ID. Now, GUIDs are actually pretty long, so we want to include references to these. And we're not actually going to be changing in either case, so we want const and const. So we have some of the basic stuff here. We have the ability for an actor to add its information and to pull its information. we're creating a save object and we're gathering the actor data. So before we go any further with more functions, let's get these created, and we'll actually add some functionality to these two. Well, 4. Oh, and I just noticed I missed something. We want this get actor data to again be accessible to blueprints. So create that definition quickly, and we're going to go through and create some of this logic here. So we'll start with create save slot. This one is actually a pretty basic and simple one. We have our save game object, which at this point is just a, actually I put a null pointer on there. No, I didn't. We want this to be initially created as a null pointer because we haven't created anything, and there's actually going to be some additional logic we use that checks this. So, but anyway, save game object is equals cast to a UTF save game, and actually we're going to need to include that header because it's going to complain about being an incomplete data class. And then we want to use uGameplay statics, which we need to include the include for. And this one is Kismet. Kismet. Wow. Include Kismet gameplay statics. uGameplay statics. Create save game object, UTF save game object, static class. 1, 2, 3, 1, 2, 3. All right, so that really, all this is saying is create the save game object, and this is the class we need to make. Oh, and actually, one thing we need to do again, so as you can see, we want this to have a U property. Otherwise, garbage collector will clear it up. All right, so this one's pretty easy. And then both the get actor and return add actor are pretty easy as well. So this one, we're just going to go save savable actor data, give it the key of the actor ID equals actor data. Now this is something that is unique to maps. Basically what we're doing here is, or if you're familiar with C#, it's a dictionary, is the closest comparison. We're adding in a key value with the actor ID and we're setting it to this. And what'll happen by default, if this isn't in there, it creates it, it adds it. So we don't need to do any, is it there? If it's not, create it. This will just go, okay, if it's already in there, update it, and if it's not, add it too. So, and then we can go return. Actually, we can just copy this. Is that going to work? Just wait for that to load through. That should return the data for that one. So let's just do a quick build to make sure. And I'll just pause while this is built because I know this episode is starting to run on. All right, so I actually canceled the build process because I noticed there was some errors being thrown, specifically in save game. So apparently, and again, this is my mistake, it does not like, let's go back to that first one in here. It does not like the incomplete class of the fsave data actor. You can see it's in here on line 15, doesn't like this. So this was a mistake on my part. We do need to include this reference in our save object. So we're going to put that up here just before the TF save game got generated, and we can go through and clear the use of struct within these definitions, or declarations, I should say. So we'll try building this again, and if there's any more errors that come up, I will again stop and come back to you right away. And we're back again. This one just happens to be a really stupid mistake on my part. We have the constructor defined here in the header, but we don't actually have it in the source file. So UTF game instance. So let's try this one last time. They say third time's a charm. All right, so again, I'm going to pause and assume, oh, there we go. It's done and it's built. So fixing a few of the mistakes I've made. And with that, again, that goes to show why I'm always saying build frequently. It saves you doing a ton of work and then not knowing what did I do that's causing these problems. So anyways, so we have all of this in place here. Now, the one other function I'm going to run through quickly, and this is after that we'll end the episode there because this one gets a little long, is this gather actor data. So with that, I'm actually going to add the include right away. We need to include engine utils for a particular data type we're going to be using here. So now with the gather actor data, we want to have a for loop, because what we're actually going to do is we're going to be iterating over every single actor that is currently loaded. So f actor iterator it, and that is going to be get world, and that's how we're going to be going through and grabbing every actor from the world, and we want to increment that as we go through. So now we don't need that semicolon in the end. So what this does is it gets an iterator, well, it's an iterator that is going to go through literally every single object in the game world. You may think this is overkill, but it's actually surprisingly fast. I've actually tested this with, I think it was 50,000 actors, and of those 50,000, 22,000 of them had save data. Now, a lot of those were just debug actors, but it was incredibly fast. So we want a actor, and we want this to be a pointer to the iterator. So now, first thing we want to do is actors can either be in the process of garbage collection, which means they've already hit the point in our code logic where it's like, okay, actors unloading, pass your information off to the game instance. If it's hit garbage collection, we've already done that. So we can go if not valid, well, not is valid, actor. And what that'll basically do is, okay, so this actor is already in garbage collection. The other thing we can do, and this is why we're using that save interface, not actor implements you save actor interface. So what we're saying with this particular if statement is if we're in garbage collection or the actor doesn't use our save interface, we just want to continue on to the next. So in the case that it does, we want to go I save actor interface pointer enter equals cast to an I save actor interface actor. So what this is doing is this is just basically saying it doesn't matter what class this actor is, we're just going to be using information that we can get from the save actor interface. Then what we can do, and this is just a fail-safe. How was I doing this? Oh yes, that was it. If enter equals a null pointer. Now this particular use case should never happen. However, it is a precautionary just in case. Because, and just to explain why, right here, this particular check should mean this is always valid. However, I throw this in as a precautionary because sometimes, in extremely rare circumstances on a really powerful machine, this could be valid, even though it's not. I don't know the full details. I've seen it happen like once in I don't know how many times, but I add this in, as I mentioned, just as a failsafe. So this is where we would need to go through and start accessing the save game interface. We've gone through, we've found the actor, it's got that. So I'm just going to run through some basics here though, because next episode we're actually going to expand on that interface. So we're going to have fguid act ID equals, and this is just an example for everyone, so we have a rough idea. Enter get actor ID, and then we're going to have f save. So this is just something very basic to try and run through this quickly with everyone to explain what's going on. So what we're going to be doing here in the next episode, we're going to, as we've already started, go through the world actors in the world, go through each and every one of them. We're going to cast them to an actor because, again, everything's an actor in Unreal in the game world. If it's not valid or if it doesn't implement the save interface, we don't care about it. And it's actually this part right here that is what makes it so fast using this process. And then we've got a reference pointer to our actor, but we're treating it purely as the save game interface. We don't care about any of the actor specific functionality. We're only using the save game or save actor interface functions. And then we're going to be getting the additional information here. Now, the actor ID one, plain, simple, straightforward. It's actually this get save actor data that is going to be a little more complicated. Now, before I end the episode, I do want to give credit where credit is due. This particular save game is from a tutorial provided by Tom Looman. Loomis? Let me just make sure I've got the right one here. I don't want to be referencing the wrong Tom Looman. Sorry, I am very forgetful. Let me just pull this up here and I will make sure to give full credit where credit is due. So here we go. This is, let's pull over just this here so you don't have a bunch of other stuff that's not relevant. So this is the tutorial that this was all based on. I have done some additional changes over and above this, but you're going to see here like a lot of similarities. And like I said, full credit to Tom Looman. This is derived from his work, and I can't take credit for any of this. So with that though, I will end the episode here. So thank you for watching, folks. And next episode, we're going to continue on with the save game interface side of things. And that should actually get us wrapped up to a point where we're ready to start using our save game. Until then, thanks, folks, and I'll see you in the next episode.